I'm going to talk about like a situation when you have applications running on old Java EE servers. Maybe you already migrated to some other technologies like Spring Boot, but maybe you have some application server, but that's not so easy to migrate to Spring Boot. We'll see what are the other options or how it compares to migrating to Spring Boot or some other technologies. So first, some words about me. I'm a Java champion, Jakarta EE committer. So you see, I'm a bit biased. I will always tell you that Jakarta EE is better than Spring. Just kidding. No, Spring Boot is actually quite good, but sometimes there's a value in other areas, and you don't want to spend so much time into migrating. And I want to show you that you don't need to be stuck in servers that are old, or do the hurdle to migrate to Spring Boot. There are other options. In some cases, more beneficial and will get you faster to where you need to be. What I observed from a survey, I was pretty surprised. This is 2 years old survey, but I think it's kind of balanced because it was run by JetBrains, which is not affiliated with Jakarta EE or anything like that. And we see that almost half of the respondents who use any application server, they still use WebLogic and WebSphere, which means those are the servers that don't even support anything newer than Java EE or Java 11. So there's no option to upgrade the server to a newer version and get something more modern. From the others, still another quarter is using an older version of an application server, Java E7, Java E8. So only 1/4 has actually upgraded to a newer version of their server that supports newer Jakarta EE. So that's quite sad. I hope that since 2023 it improved. There is a more recent survey by Acris Foundation, Jakarta EE group that shows, or at least according to the survey, there are much fewer people using WebLogic and WebSphere, more people using other open source application servers that have easier paths to upgrade. But I don't know if this is really shows what the reality. Because this was run by the Jakarta EE working group, and I think it's more skewed towards Jakarta EE. Probably a lot of people that use Jakarta EE responded, but fewer people outside of this group or who follow. From those who don't follow so much Jakarta EE, probably responded less. So with this situation, I expect that there are still some or quite a lot of installations of our old application servers. I wonder, there are not so many of you here, so maybe if you'd like to share what's your situation, if you still have an old application server running, what are your plans? Yeah. If you...
We're running PR.
You're...
Yeah. Java EE, not Jakarta EE.
Yeah.
We haven't resolved it. Really, it's a small company, so the plan is mostly different how to use Java. But I'm not my company.
Yeah, I know. Okay. I see. It's interesting. It's not the first time I hear somebody saying that they're not even going to upgrade their Java stack. They're migrating to some other language or some other non-Java technology. I don't know how it will work out. I would like to talk to those people in 5 years if they were happy or if it wasn't for like better for them. I don't know. I still think that in Java ecosystem it's much more stable and a lot of options and will survive because Java EE and Jakarta EE has been here for 20 years, I think. I still just recently work with companies that upgraded from an application that was built more than 10 years ago. They upgraded to Jakarta EE10, and they can still run it with modern Java with updates without any hassle. I can't imagine that would happen with Python or JavaScript, or even Go or any other language. So I wonder what will happen. So, yeah, just to summarize, I don't have anything against Spring Boot if you use it wisely, and it's just a tool that a lot of people use. There's a lot of resources about Spring Boot. It's kind of lightweight until you misuse it. I saw a lot of times it was misused, and actually the application built on Spring or Spring Boot was almost like an application server bundled into an application, and then it took long to start, and it wasn't in any way better than an application server. But it can help. It's constantly evolving, so I can see the value in migrating to it. The biggest problem is that it's very incompatible with Java EE. So there are ways how you can even use standard REST APIs, and like Spring supports that. That's not the preferred way, but you can still migrate REST services written for Jakarta EE to Spring. But if you want to do it in Spring native way, you would still have to refactor and use the Spring annotations so that it feels natural in Spring world. In some other cases, you're out of luck. If you use dependency injection, good luck in trying to port the CDI code to Spring. You have to really refactor things. There are tools. I talked to modern people who are behind Open Rewrite. They have tools to help with migration from Java EE to Spring, but it's still a lot of work to do and a lot of review. After you automatically change the code, you still have to make sure that it's still running. So, my experience is I talked to several people who already did this Spring Boot migration, or most of them just started or are somewhere in the middle. Because my experience is it takes much longer than people think. And there are basically two approaches which I saw. One is with a client that I'm working now for some time. They started rewriting parts of their monolith into Spring Boot applications, self-contained systems which are connected by Kafka to the monolith and between each other. They try to write new code in these services when they have time, or it makes sense. They try to split some modules from the monolith to new services. But the reality is they're still not even halfway in this migration. After 6 years, they migrated around 30% of code. 60% of the original code is still in the monolith, and they have to still maintain the monolithic application on an old server. They are slowly upgrading the server, but I think they're now in Pyre 5, and just like a year ago upgraded to Pyre 5, which is already like 3 years old. And they are just catching up with this, struggling to maintain the old application. But they already have Spring Boot, and recently they started to use Quarkus. So you see that the technology is now fragmented. So it's not so easy to switch from one to the other. A lot of the time you end up with having different technologies, which is not ideal, because then we have to have developers who understand all of them. And since Spring is different than Java EE, people are kind of weird. They tend to prefer their own the technology they like. So you either have people who like Java EE and they don't like to touch Spring Boot, or you have Spring Boot developers who don't like to touch Java EE. But in reality, you have to touch both, because sometimes the business requirement requires you to touch the services, the new services, but sometimes you have to touch the old code because it hasn't been migrated.
May I ask how many lines of code and how many developers
are I don't remember. I don't know how many lines of code, but it's tenths of thousands of classes, definitely. And it's around, I think, around 80 people. It's a big application that provides a lot of different, it's like a gaming industry, so it supports a lot of online games, lotteries, a lot of different things. And now what is the struggle with the old monolith. That's why they want to also go to microservices. is that one monolith is shared by multiple teams, which have almost nothing in common. Sometimes there are conflicts and they cannot release at the same time. They have to wait. One team has to wait for the other to release and then rebase on their work. So there are a lot of conflicts there. But it's because they started migration too late, and it's not about Java EE. They could still use Java EE on microservices, but it's the design of their application is that it's basically evolved into a big monolith that is not very maintainable. Mm-hmm.
You know how much of the code which was already rewritten was necessary to change again because of the upgrade of Spring?
I don't know, but in the area that I'm helping them with, they decided to basically rewrite the mechanism from scratch. It's written in Spring Reactive, almost for no reason now, but they expected high loads on the service, then they chose reactive programming, and in the end they found out that the load is very low and they don't need that, but it was too late to rewrite everything back to normal code. But that was rewritten from scratch, and it kind of works. It's better than if it stayed in the monolith, but now you have different problems. But it's not because of Spring Boot or Java EE or whatever. It's because of microservices. You have to synchronize data. They have different databases, so we have to think about sending a Kafka message if something updates in the database to the second system, and you have to synchronize basically everything, and there's a lot more work than just keep everything in one place. But another thing is that they don't really have, their monolith is not modularized. So even though ERs are not very popular now, ERs in Enterprise Java allow you to create different modules and then package them together in one file. And in reality, you need to package them. You can just deploy each of them separately on one application server, and then they work together. But here in this monolith, it's basically just one WAR file that just gets deployed and it has everything inside. So that's a different story. Another case, I don't have much insight into this, but I talked to a person at a different conference, and it was basically after this talk, they gave a similar talk like this. They told me this is exactly the situation we are at. We thought that we will migrate to Spring Boot in 6 months, and I told the team it won't be so fast, but they were so keen on migrating to Spring Boot, and now we are halfway through. It took already more than these 6 months, around a year, and another 1 year it will take to finish it if we finish it successfully. So in the end, I think it was a premature decision because they didn't consider other options, other things that were more compatible with Java EE. They just wanted to use Spring Boot, which makes sense because if they are there, maybe Spring Boot is better. But the path to get there is very sturdy and with unsafe results. So I would recommend to consider also this. And it makes sense if you start new services with Spring Boot, you also want to have your own code in Spring Boot to avoid having multiple technologies to maintain. But there's this cost. If you already have something in Java EE in application servers, cost to rewrite is quite something to consider. And then it also makes sense maybe to write new services not in Spring Boot, but some other option that I will present that will keep you in sync and then allow you to have some similarity in new services, new code, and the old code running on application servers. So what are then the options? One thing is we could just upgrade to a newest server, like with this Pyre 5 case. Your company could upgrade to Pyre 6 and be happy, probably. Or if you don't have status server that allows this upgrade, like WebLogic or WebSphere, which still don't support Jakarta EE 9 or 10, still require Java 11. Then you can migrate to some other server. So there are a lot of other alternatives if you use servers like that, WebLogic or WebSphere. Even if you use others, like there's always good to know what are the options. So if you're not happy with one application server, you may see what else is there. Sometimes even what also matters is the level of service that you get. If you're interested in commercial support, you get different levels of services from the companies that support these servers. And there's a whole list of compatible servers on Jakarta EE website. And a lot of these options are open source. So it means that you can save on the licensing costs if you have servers like WebLogic. Yeah, was there a question? Yeah. One example that I want to present is Eclipse Glassfish, but a lot of it also applies to all of these, Wildfire, Payara, OpenLiberty. Payara is actually a fork of Glassfish, still very similar to Glassfish. So it's all of them are more or less equal. It's just then the devil is in the detail, but it's up to your project, up to your needs. So what I want to show you, for those who don't know, I think you with Payara might be quite happy. But compared to WebLogic or what many people perceive as application servers, these new servers, including latest version of Glassfish, are very fast and lean. They start in seconds. They don't eat a lot of memory, but they still have all the enterprise options there. It's just they are not loaded when you don't need them. But when you need them, you load the administration console. You have an UI to configure and everything. You can have clustering without adding any additional dependencies. You don't have to add Infinispan or Hazelcast to it. You just have it there. And you also very often have an option of commercial support. So with Glassfish Server, like I'm not going to argue. With Spring Boot, you might have more like benefits, maybe even better development experience. But if you already are in application servers area, Glassfish Server still provides a decent alternative. It starts fast. What is even simpler to Spring Boot, you don't need any dependency if you are okay with what Jakarta EE provides. You just use Jakarta EE API artifact and then everything is there. What I always struggle with when I want to do some demo with Spring Boot or even other technologies, I need to generate the project because I don't remember which artifacts I need to add to have REST functionality or database functionality. With Java, you just add one artifact and everything is there. So that's quite nice. You can also have fast development cycle. It's maybe not so polished as with Spring Boot, but if you have a decent IDE with a plugin, it will automatically redeploy your code as you save it and restart the application. And it doesn't restart the whole server. It only restarts your application within the server. So you save on server restart times. There's also other modern things that people would think like, would application servers work in Docker? Yes, they do, at least Glassfish and many others. Where application servers are not so good at, most of them, is when you really want to go small or serverless functions. They are not very designed for that. They are designed to support enterprise applications. We can go very small with microservices, but if you need to go even smaller with serverless functions, when you don't even have an HTTP server, because the HTTP server is provided by the cloud, and everything the cloud needs is to call your method and get a response in form of an object or a JSON, then application servers are not really designed for that. I would argue that even Spring Boot is not designed for that. It just has a solution for that, but it's still not designed to start fast with you prefer in AWS Lambda or serverless functions, where every invocation can mean restart of the whole application. Then there are other options which you have. But yeah, here we are with this simple, straightforward option just to upgrade or migrate to a newer application server. So what do you do? If you want to upgrade to a modern server, you need to upgrade to from Java EE to Jakarta EE10, which is kind of straightforward, but there's one obstacle, which I will mention in the next slide. But besides that, there are very few breaking changes. Jakarta is still very stable, and unlike Spring Boot or many proprietary frameworks, it doesn't change. As I said, I was able with a client to upgrade an application that they created 10 years ago or even 15 years ago. They upgraded the latest Glassfish 7, and they didn't need to change much in their application. And this case, in one case, it took like 2 weeks to just do all the replacements, and we didn't have enough experience with it, so now we can automate it because there are tools to automate, and I will show you in a few moments how to apply the tools in like 1 minute to automate everything and be there. The bigger hurdle was when this application was not written with Maven, it was written in Ant. So we also had to replace all the jar files here and there and download from internet. You can imagine, like, I don't know if you still remember when the times of Ant, without this automatic download of artifacts. We used to store them in a CSV or SVN, the jar files. So that gets complicated, but it still shows that even applications old like that can be quite easily upgraded to Jakarta EE. So the thing that I kept for later is this hurdle, and this is because Jakarta EE was donated to Glassfish Foundation by Oracle. Oracle was kind of nice. They donated everything, but they forbid to use the Java in the name. That's why it's Jakarta EE, and also in the code, in the APIs. So JavaX can no longer be used as Jakarta. Otherwise, everything else is the same. So the change will be straightforward, just to copy, or search and replace. But yeah, you will find out that it's not that easy, although it's not complicated. You will have some cases where it doesn't work. Sometimes JavaX doesn't change because it's in core Java. Sometimes you have JavaX also in some non-Java files, like in XML or some property files. But luckily, there are automated tools. There's Eclipse Transformer and there's Open Rewrite. I tend to use both of them because recently, after there were upgrades in recipes for Open Rewrite, it can do most of the work, but there's still some transformations that are missed. So Transformer completes that. And there might still be some little edge cases here and there where we need to do some things manually. But if you combine these tools, you will get like 99% or even 100% there. And now I can show you how fast it is to just upgrade to the latest server. So here, I have an example application cargo tracker, but it's quite good to demonstrate this because it's an application that demonstrates almost all the features of Jakarta EE. There is inside that application, there is almost every API used, REST API, messaging, batch processing, almost everything that you would like to see is there as an example. So it's not really hello world application. It's not a big enterprise one, but it's already quite decent one. And I will not be able to run it on Glassfish 7 because it still uses JavaX namespace. So I can run it on Pyro 5, for example. I'll just start it to show you what it does. But what is interesting is how fast I can change it and update it to new application server. And I have two commands. One is the open rewrite, which I recommend to use first. And I have on Omnifish blog, there are several series of articles which I wrote based on our experience with upgrades and using these tools in reality, where I described how to use them. So this command will be there. Also where to download the files and in which order to apply them. And then some other cases which are not so easy. But in this case, we don't have many dependencies in the application. So it's pretty easy because everything is just our code. There's one dependency on prime faces, one I think on JAX-B, but that's it. And if I write it like this, the open rewrite will try to scan my application or the source code, upgrade everything that it can find, and in the end tries to compile. And ideally, it would be possible to deploy on a new server. I won't run it because it takes around a minute or so. So I will just show you the results. The results are like this. So in code, it automatically changes DevX to Jakarta, but only for those packages where it can change it. So it will not change it for packages which still should have JavaX. That saves you some amount of manual work. But also what is interesting, it knows in the recent recipes, it understands how to find out the Jakarta EE version if you have it in the POM file, so it already does that, upgrades to the Jakarta EE10. But it also recognizes old dependencies which are not compatible with Jakarta EE10 because they still use the JavaX namespace. So it discovers this JAX-B runtime, upgrades it to a newer version. It discovers prime faces. It finds out that 8.0 is not compatible, so it upgrades to 14. Now there is a version 15, but 14 still works. But it also understands that in this case, prime faces require this Jakarta classifier. This is because this prime faces dependency is still to support older Java EE if you want to run it, for example, on WebLogic. So you use the normal version. If you want to run it on Jakarta EE10, then you use the version with the classifier Jakarta, and it will download alternative artifacts with the Jakarta prefixes. So again, quite nice. Automates almost everything. Except a few cases. So it's good to run also, this Eclipse transformer. And again, I would just show how to run it. With open rewrite, everything is replaced in place. So you don't have to do anything, it's automatically updated. With transformer, it copies or it creates a copy of transformed files. So what I do here is I delete the previous source code directory and I move the new one to the original one. So I want to replace it. And then I will show you the end result. What is the difference after I executed the open rewrite, or between I executed open rewrite and what transformer also additionally transforms. That's why it's good to run them both. Because transformer also understands that it should replace JavaX Jakarta to Jakarta EE in some message event beans. And it also will replace files like test files and batch jobs. So these are more like edge cases. You could do it on your own, but you would spend some time figuring out. You would try to deploy that. Oh, it doesn't work. What's the problem? We would eventually fix it. But if you use transformer, it can save you some time, especially if you have a lot of modules to transform. So it's just run open rewrite, wait about a minute, run Eclipse transformer. It's shorter, but still almost there. Why I'm saying you're almost there is because there will probably always be something. In this case, what actually is missing is just one thing in prime faces. It's not related to Jakarta or anything like that. But if you upgrade prime faces, each version of prime faces has a set of themes which there are for free, and you can use one of them. But they sometimes change this set of the themes. And the new version of prime faces doesn't have, in this case we used Omega theme, is not present in the new version of prime faces. So a simple fix was to use a different theme. Then you maybe need to adjust some CSS or whatever, but it works. I'm just highlighting this because there might be still something, but this is not related to Jakarta transformation. This is related to upgrade of the library. So this is usually easy to upgrade everything, but if you upgrade, you also can have some breaking changes. And after this, I can run on Glassfish 7. I thought that I started this on paragraph 5, but I think I forgot. Or just here. So this is still the old version of on paragraph 5, and after I apply transformations, I will change it to the latest Glassfish 7. Not Glassfish 8, that's still a preview version. But now I need to check out and run. And I will have the application transform running on the new server. I need to stop there. 5. Okay. So once again. Okay. So while we're waiting, I'll continue with the presentation. There's also another option, and in a lot of cases in these application servers have like a more modern option. So that will be another step to consider. You don't have to go with just an upgrade of an application server. If you want to write new services, you can still split pieces from monoliths to new services. But if you like to have like a similar code, or even like just take the code from monolith, put it into microservice, and keep the same code without any refactoring, without any hassle, it's better to stick to some solution that is compliant with Jakarta EE, so that you can use the same technology. And in this case, Glassfish has an option of Glassfish Embedded, which is called Embedded because you can embed it into your application. But you can also run it on the fly from command line. You don't have to embed it. And then it basically embeds the application that you add to it and runs. But so the name is not very descriptive. But in the end, it's like Glassfish lightweight. You can run it from command line in the same way as Spring Boot, or you can embed it to your application and control it from code. And it's more lightweight, it starts faster because it doesn't start the administration console and some other things. And it's more suitable for small applications, for deployment on Docker. And it's quite reasonable option if you really want to stay with the Jakarta East technology, but still stay also with something familiar but more fine-tuned for cloud deployments. So let's see what the application does. So this is now the application running on Glassfish 7. Looks the same. If you would pay attention, yeah, so the theme is kind of broken because there's some custom CSS style that relied on the previous theme. Now we see that when we change the theme, it got a bit broken, but that's at least a proof that we're running on a new server with our changes. To show you how it looks with Glassfish embedded is, let's have an example of a module that we want to extract as a service. If you wanted to extract it as a Spring Boot service, we have two options in this case, either to configure Spring Boot to understand our Jakarta REST code. But if we have dependency injection and other things, it's much harder, even probably impossible without code changes. Or we rewrite everything with Spring Boot annotations like REST controller, red mapping, and things like that. Imagine you have to do that for like hundreds of services. That's really complicated. You would use some automated tool, but still not so straightforward. So with Glassfish embedded, you can do that just with copy pasting the code. So that's what I did. There's a service inside the application. This graph traversal service, that the WAR application contains this endpoint, and I want to extract it. So I have exactly the same code. I just need to copy all the dependencies. So now everything looks prepared. In real world, it wouldn't be like this. This is a demo application. But everything I need for this endpoint is in this Pathfinder package. If I copy it to a new project, I will have the same thing. No change in code, just copy paste the same classes here. And basically by default, I don't need to do anything because I can run this, as I said, on command line with Glassfish embedded. I forgot to add command line option. So I have passed the Glassfish embedded jar in this variable. We can echo Glassfish jar. It's just passed to the Glassfish embedded in the Maven repository. So I just call it to start Glassfish embedded, and I give it path to the build application. So that's it. If I want to run it on a different port, because I already have the big demo application on port 8080, I can specify port equals 8081. And then I start it. It starts a little bit faster than Glassfish. It even shows me the URL of the application. So again, I can execute it, but it's a REST service. So here I need to invoke it with a little more details. And I forgot to prepare the URL. I think I have it in history. Yes. So no, it's not like this. It's like this. So now I can call the service. It runs separately from the monolith, and I really just needed to copy paste the code. So in reality, it simplifies things, and you can still keep your knowledge that you have, even though it's very tempting to learn Spring Boot's API. But if you already have knowledge of Jakarta EE, Java EE, JAX-RS in this case, you just copy paste. You see the code in monolith, see the code in the service. It's all the same. You can understand it. What is even quite nice is that this code uses EJB stateless. So there is a replacement. There are replacements in Spring, but stateless. If you already have it there, you don't need to rewrite it. You could rewrite it into transactional and maybe some other things that EJB provides, but you don't have to. Another nice thing is that it already combines with validation. And you don't need to add anything there. This is what I mentioned in the beginning. You just have Jakarta EE API artifacts. And you have not only REST, but you have validation. With Spring Boot, it's not that I would complain, but if I want to do a demo, and I forget in the code generator, I forget to add the validator, generate the application, I run it, then I need validation. How to get it? I need to generate the code again with the validation and then copy the validation artifact there. So I still have the hassle of setting up a new application with this. It's like, okay, don't do it every day. But for demo, it's very nice. You have just one artifact and you have everything at your fingertips. You can use any annotation or API from Jakarta EE with Glassfish embedded or any Jakarta EE server. And you can be very productive with just setting up new projects. So this is a way, an alternative way, if you're willing to go, or if you want to microservice, if you don't really dare to use Spring Boot, then and you have some code base already in Java EE, so there's a way how to run it as microservice effectively. There are also alternative options to things like that. So you don't have to use an application server. There are so-called runtimes. I also call Glassfish as a runtime because there's Glassfish embedded. It's no longer the full-fledged server. But these are a bit different. They are redesigned from scratch, and they're more like combine the power of server and application together. And in the final application, sometimes it's not so easy to say what is server code, what is framework code, what is your code. Everything is bundled together. Especially in case of Quarkus. It has a lot of optimizations at build time, so it has even faster startup time. It can start even in a second, low memory. What it has nice, it has really productive features. Like it has dev mode, so you can start the same application in production without developing features tuned for production. But in development, you just run it in dev mode, and you have a lot of things that help you, like hot redeploy, or even automated tests running when you change code and things like that. It has a lot of integrations, so it tries to compete with Spring Boot, bring in integrations for almost every library out there. And where it's really outstanding is in native binary compilation. So if you really want to go to native binaries with GraalVM and you want to have a framework, Quarkus is one of the best options, because it really has support in its extensions, support native compilation. For libraries that it doesn't support, or for your own custom code, it has a special annotation that marks this code, that then Quarkus will know that it should instruct GraalVM, that it should generate some metadata for reflection. This is basically for reflection, because reflection works in native binaries, but the compiler needs to know about the code that will be called effectively. If it's not called directly, and you don't instruct to keep the code, it will just ignore the code, as if it didn't exist. So we have to tell him, yes, I will call this reflectively. You won't find it anywhere in the code, but there's some class load for that will be called, so keep the code there. And it can be very productive. There is also a slight downside that with this approach of Quarkus, it's similar to Spring. For every functionality, you have to add a dependency to the project. So you have to remember or find the artifact that you need. Another alternative would be Piranha Cloud, which is a project that basically our company started with collaboration with some other people from the community. It's like an alternative to Quarkus built on Glassfish components with a new servlet container, designed to start very fast, but also designed to be very flexible. So this is a different approach to application servers, because application servers were designed so that everything works together. They were not designed to be modularized. And Glassfish, even though it has modules that run on OSGI platform, some modules really require other modules, and then you cannot really replace everything by custom solution very easily. You can, but there are a lot of interfaces with like tens of methods that you would have to implement and bridge to your solution. With Piranha, the core is very flexible. The interfaces usually have one or two methods that are easy to implement. And there are different extensions already out of the box that you can plug in. So for example, you can have a small servlet container, and then you can decide on the HTTP stack. You can write your own HTTP server that just converts the incoming HTTP request into an object that the engine understands, and then converts it back to HTTP response. There are HTTP stacks that work with virtual threads, so they do this conversion and run the engine on a virtual thread. So you can use different kinds of HTTP stacks, or in some cases, you don't even need or want HTTP. In the case of serverless, or in AWS Lambda or other cloud providers, the cloud provider actually just calls your method and wants to get a response as an object, not as a real HTTP response. So then you really want to bypass and skip the whole HTTP stack and just call the engine. So this is possible with Piranha. This is also possible with Quarkus, but Quarkus does it in a different way. It basically has some framework to do that for you. And the cloud doesn't call your method, but it calls Quarkus method, and Quarkus then delegates to your methods. With Piranha, you can have full control over it. You can see what's happening and react directly to what how cloud calls you, and then convert this to an object and have more control. So more work maybe to set up, but then it's easy to understand what's happening. And it's a newer project with a small team that is behind it, so it doesn't have so much resources to get started, and it's still more like an experimental framework, but it shows what is possible. So in one way, it shows that it's not Jakarta EE that is blocker in innovation. It's the old servers. So if you rethink the implementation of Jakarta EE, you can see that it's possible to create very small server with all Jakarta EE components, start very fast. It's just mentally, a lot of people think like Jakarta EE, that's old EJB stuff, and it's all bloated servers. But with standards like Jakarta EE, you can really use the same standard and replace the engine. Either use a big application server that provides a lot of other enterprise options, or really use just core Jakarta EE components and choose a framework that allows you to either start fast or be more flexible or whatever you need. So just shortly, I will show you how that looks like with Quarkus, if you don't know so much about Quarkus. So I will do the same that I did with Glassfish Embedded, but for Quarkus, I need to create a separate project because Quarkus requires some special build setup. If you look more closely, it kind of resembles me what Spring Boot does. I think there's no parent. The approach is a little bit different. With Spring Boot, you have a parent and you extend the parent. With Quarkus, you don't need a parent, or you can have custom parent, but then you have a plugin, which is here. And the plugin basically hooks into Maven and can customize the build process. So it generates some code, it scans the source code, it does some optimizations, it even changes how even the extensions that you add, because you can add some other dependencies here which are actually extensions to Quarkus. They can hook into this plugin and change the end result. There is an extension for AWS Lambda, which modifies the build so that you don't have a normal service that runs, but it creates a zip file that you upload to Lambda, and it's in the form that AWS Lambda requires to deploy. And even it will create a shell script that allows you to call them Lambda if you supply AWS credentials. So this is the way how Quarkus works. It's kind of magic, but it does a lot for you. And it has the dev mode. If you start it with a dev mode, it again changes what you have in the end result. It will not generate a zip file because then even if you call it, if you change it to the jar file and you call it, you cannot invoke because you don't have REST endpoint because that's not used in AWS Lambda. But in dev mode adds a REST server on top of it. So it will start the same code, but it will wrap it into a server, and then you can call it directly from browser. So let me start this project. No. Yeah. I'll start it just from command line. Normally, you would start it with Quarkus dev. And you see that this is the Quarkus plugin that basically does all the heavy lifting, optimizing everything, and then it starts the application in dev mode. And now I think, now we can execute the same thing, but now it goes through Quarkus. The difference in code is not so big because Quarkus also supports the same Jakarta REST API and JSON mapping. So in the end, we just remove the stateless annotation because Quarkus doesn't support EJBs. But it automatically turns this into a CDI request call bean. It is more or less the same as stateless. So there are now slight changes, but still like 99% of the codes can remain the same. And with Piranha, it's again, the end result can be very similar, but the approach with Piranha is different. With Piranha, actually, you can have two modes of operation. One is embed Piranha and then control it from your code, which is usually what you would do in like serverless containers. But you can also run it from command line in the same way as I executed the Glassfish embedded, because Piranha also provides several distributions, from small ones, core ones, which have just small amount of functionality, to bigger ones, or even like the full package, which is almost web profile of Jakarta EE. And then you just run your application with it in the same way as I did with Glassfish embedded. So I can even run the same Glassfish embedded application. The trick is, even if there is stateless, and Piranha doesn't support stateless in Java, if annotation is unknown, is ignored. So Piranha will ignore this stateless annotation and will still work in a similar way as Quarkus. So I could start it with Piranha. Again, it's minus jar. I have Piranha here. I have it prepared here. I set it to start at app context because for some reason there is a bug in a recent version that doesn't start on the context root. I can specify port here, and I think we don't need this. So similar way as Glassfish embedded, I can run it from command line. It will just bring application started, and again, it's just I need to change the context root to app. What did I do? Oh, it should be there. I think I made something wrong. Yeah. Sorry for that. it shows Piranha is not very stable, to be honest. So I don't want to like make the impression that it's like cool new thing there, but it still is quite promising thing that we're working on, and hopefully we'll get it to something usable very soon to provide an alternative to Quarkus or some other frameworks. But to summarize, we have still like very good option is Spring Boot because it's used by many people out there, many projects. It has a good support. But in case it's complicated to migrate to it, then we have good options also in application servers, which can be very fast, modern, run on recent Java and provide Jakarta E in the recent version. And if you want to go further, we still don't have to go to Spring Boot if we don't want to. There are runtimes like Quarkus or Piranha or even Halidon, which I haven't mentioned, which start even faster, has some unique features. So I recommend to look there also. And that will be it. If you have any questions or any insights, I'd like to hear what's your experience or whatever you want to say and share. Yeah.
The Eclipse transformer tool use recites like open rewrite, or how does it work?
Excuse me again.
Eclipse transformer tool.
Mm-hmm.
It has recites. Like
Recipes. Yes, it does have recipes. It's very similar, like it's implemented in a different way, but yes, it has default recipes. That's why the command line didn't specify the recipe. So the default is because transformer tool was started to actually help with this Jakarta transformation. So by default, it transforms Jakarta. It can support some others, but it's not so actively maintained as Open Rewrite. So it primarily supports this transformation to Jakarta E9. The unique feature of Transformer is that it can also operate on binaries, which Open Rewrite can't. Open Rewrite will only modify your source code, your POM XML file, so it can upgrade the dependencies. But if you have like a whole WAR file or ER file, you're out of luck with Open Rewrite. With Transformer, it can transform. Maybe it's not 100%, but it is able to transform the class, the bytecode in there to use the new package names. It even goes to XMLs in the ER files or WAR files and transforms them. So it will create a copy of the binary WAR or ER file. And in reality, with simple applications, you might be able to run them out of the box. With more complicated applications, you still might need to change things. I saw that sometimes like changes in XML descriptors were required somewhere because Transformer misses some edge case files. But usually I try to do that first to see what is the amount of work to do to transform. And even in this complicated setup, which I mentioned, when we had Ant built a project, we first managed to build the project against Glassfish 4 in a normal way to produce the ER binary. We modified it a bit to modify the descriptors which Transformer did miss. But in the end, we applied Transformer and we were able to deploy. This is not ideal because every time you change code, you have to transform everything again. But it's like an intermediary step that helps you run on your server before you can upgrade everything. And there might be some cases where you have dependencies which don't have a new version that is compatible with Jakarta prefix. And there you can still apply Transformer just on that one dependency. Upgrade everything, and you just go this dependency. You transform it to use Jakarta, and you don't have to upgrade it, and that works pretty well. So Transformer would be like a killer feature is to transform the dependencies that you cannot just simply upgrade. That's very useful. Besides that, open rewrite is much more powerful and has much more recipes.
I have two questions. The first, the Perennial server uses CDI, right?
Yes, it uses well.
The one I'm interested in. I remember that you discussed about the option to rewrite the EJB annotations in terms of CDI.
Oh yes, there is an experimental project that is not part of Piranha yet, but there we started an effort to like create a mechanism of extensions on top of CDI to provide the same functionality as EJBs. So to run EJBs, you need normally an EJB container, which provides more or less the same functionality as CDI, provides dependency injection, but it works in a way that it automatically enables transactions and some other mechanisms just with one single stateless annotation. So that's the idea. We don't want to migrate the EJB functionality from Glassfish to Piranha. If we provide EJBs in Piranha, it would be this way by some extension over CDI. Yeah. So if that's all, thank you very much for attention. Yeah.